Elyse Fosse. I've been at JPL for 7 years, and I currently work on the Mars 2020 mission as a flight system engineer as well as a mission system engineer. I made a new role for myself. It's called the MBSE Cognizant Engineer, so the CogE. Primarily because I don't own the information that's in the model. The electrical systems engineer still owns the electrical functions, and the thermal engineer still owns the thermal characteristics. But what I own is how do you integrate that information together? If we're looking at electrical functions, how should they relate to the thermal characteristics? How should they relate to the physical characteristics? How should they relate to process? And so my focus is on the integration structure as well as teaching people and making tutorials so that I don't want to be the bottleneck I don't want to be the data entry person, honestly. I don't want to be the one who the thinking is owned by somebody else and I just have to put it into the model. And so I want to work with my role as the CogE, MBSE CogE, to be the one who's motivating people to integrate the information and providing them the framework for that, and also scoping what we're putting into the model and understanding what is the right tool for the use case we have. Not everything fits into one piece of software, and not every model looks the same, and we shouldn't be trying to make anything uniform. Rather, we should be understanding what are the use cases and really applying an architectural approach to how we implement a model-based approach. A model really is just a conceptual representation of something you're trying to understand. And that can be as simple as writing something down or on a napkin, or something as complex as a systems of mathematical equations. For a systems model in particular, what we're really focused on are the aspects of the system that we're trying to design. So that's your requirements, your structure, your behavior, as well as the analysis of those against your implementation. And the reason why you would want to be implementing a model-based approach to a systems model really depends on the questions you're trying to answer, as well as the complexity of your system. If you have a light bulb, for example, probably don't need to model that. That's something we can all grasp. But when you're dealing with complex missions and flight hardware that's going to another planet, and operations that need to understand how to deal with light time and differences in communication paths, well, then you might want to start thinking about a model-based approach so you can provide more rigorous analysis methods to the work that you're doing. Tying two models together is a hard task right now, particularly because you need to really understand the interfaces between the two models. Whenever you're tying two things together, you need to understand the comparisons between the two. Do they overlap? Where are there gaps? And in order to really understand it, it really brings about the motivation for having patterns or ontologies, so that way you understand what exists in one model and how it should relate to the other model. What that also helps you with having patterns and ontologies is it enables the ability to create validation against your models to understand completeness and consistency. Once you start integrating models together, that question becomes bigger and bigger of how complete are we? Are we consistent across all of the models? And the only way to understand that is if you understand the patterns that you've implemented underneath either or all of the models and understand how they relate to each other.